Hi students, let's continue with the examples of the mealy machine. Now here in another example. Construct a mealy machine that prints A. Okay, so that prints A whenever the sequence 01 is encountered in any input binary string. So they are saying any input binary string means it should be in the 0 and 1. Okay, so whatever the input binary string, okay, this is an input alphabet. So the input they are giving the string, like suppose whatever the string we are taken. So the question is, I need to construct a mealy machine that prints A. Okay, I have to print A on the output whenever the sequence is 01. So whenever the sequence is 01, in place of 01, as 01 is there, it has to print A. Whenever the sequence 01 is encountered, it has to print A. So that means the input alphabet is the set of 0, 1. There is a binary string. And the output alphabet O is AB. Set of the string AB. Okay. So now let me construct how to construct this mealy machine. So first construct the deterministic finite automator for the given question. So then it will be easy for you, because everything you need to consider the concept of the deterministic finite automata. So here they are saying I need to print A whenever the sequence is 01 is encountered. So whenever the 01 is encountered means it has to print A, it is saying. So total here the 2 characters are there, means total 3 states are there according to our concept. A deterministic finite automata, if there are 2 characters, 2 characters or 2 symbols are there, then the total number of states are the 3. The length is 2, number of states is length plus 1, you will get the number of states, that is the 3 states. So this is a start, let's say A is the initial state. So on 0, 1, take B. Okay. So whenever the sequence 0, 1 is encountered, let's take this is a final state C. Let us assume, but in mealy machine there is no final state. Let us assume this is a final state. Why? Because I need to construct a sequence. Whenever the 01 is encountered, it has to print, the output has to print A. So whenever it is B as 1, input 1, the output should be A. So whenever the 01 is encountered, the output it has to print A. And the remaining all are B's. Remember that. The remaining all means, so in the deterministic finite automata, each state has to construct in zeros and the ones. So it is going out 0 and the input 1 B. So the remaining, for all the remaining things you just place. So 1 is going and the 0 is B, and the remaining all things you need to construct as. So here 1 is coming and C is going to 0. On input 0, 1, it should be B. Okay. So already C is going. On 1, it is B. Okay. So this is a mealy machine. So how can I, only the thing here, whatever the string you are taken, okay, it generates whenever the sequence 0, 1 is encountered, it prints A. Okay, suppose if I take a simple 0, 1, 0, 0, 1, the final output it generates is A. Whenever the 0, 1 is encountered, it prints A. Okay, so let me take 0, 0, 0, 0, 1. In case of 0, 0, 1 also, if I take 0, a 0, 1, in place of 1, A is encountered. So let me take an example to check whether this mealy machine, whatever I constructed, is true or false. Okay, so let us assume a string as 0, 1, 0. Let me take, okay, 0, 1, 1, 0. Let me take 0, 1, 1, 0. So whenever 0, 1 is there, a string A has to be encountered. Let's check. So first A on 0, generating an output B. Okay. Next, it's going to be B on 1, it is going, let me write here. A on 0, it is generating a new state B, and output for the B is, and output is B. And A on 1, B on 1, B on 1, it is going to C, and the output here is A. Now C on 1, C on 1, it is going to A, and the output here is the B. And A on 0, A on 0, it is going to the state B, and output here is B. So what is the string you got? B, A, B, B. So whenever the string 0, 1 is encountered, it prints A value. Did you observe here? Whenever the string 0, 1 is encountered, it prints A value. Let me take another example. So to check this. So this time I am taking 1, 0, 0. So in this string there is no 0, 1. If there is no 0, 1 means A should not be encountered. Okay, let's check. So A on 1, A on 1, it is going to the A itself, and the output it is generating is B. Now A on 0, A on 0, it is going to then another state B and producing an output B. Now B on 0, B on 0, it is going to B itself and producing an output B. Now again B on 0, it producing a state B and output is B. So what is the string that you got here? All B's. Here A is not encountered. Why A is not encountered? Because 0, 1 sequence is not there. Whenever the 0, 1 sequence is there, it prints A value. But here the 0, 1 sequence is not there, so I got the output as all B's. So this is how you need to construct MLA machine which for the given condition. So don't confused. So first take the minimum diagram. The minimum concept is whatever the question they are giving, you have to get the answer for that. So I need to encounter 0, 1 value. Whenever the 0, 1 is there, the output it generates should be the A. A has to be generated. For the remaining sequences, I just keep the B value. So whatever it may be, I don't bother about thing. But the concept here is whenever the 0, 1 is encountered, it has to print A, and the remaining for all I had put B. So why you will get a doubt, how can I draw these? Only C has to go to A, only C has to go to B, and B has to come like this. Don't bother about. According to the DFA concept, okay, each string will generate on input 0 as well as the input 1. Okay, each state, not string, each state will generate input 0 as well as 1. So here A is generating 0 and 1, and the B is generating 0 as well as 1, and the C is generating the 0 on generating the output on 0 as well as the 1. So like that, so it all the three states has to generate an output on 1 as well as the 0. So based on that condition, you need to check, and the final thing is the sequence 0, 1 should be encountered whenever A is occurred. Thank you.